Okay, I'm going to go over a few problems from Chapter 4's Quest. I'm going to go over question 3, 4, 6, and 11. But before I do that, I just want to talk a little bit about doing STOIC or factor label involving molarity. It's the one area of STOIC that students struggle the most with. So let's take a look. So it's important to know that molarity is the moles of something over the liters of something. And if you look at this, this is a derived unit, so it can be used as a conversion factor. So if I have something that's 3 molar, then I can use a conversion factor that says 3 moles of that substance over 1 liter of that substance, or 1 liter of that substance over 3 moles of that substance. And recognizing that it's a conversion factor is probably the most useful thing that you can do. So if you're given a problem where you're given molarity is usually not the right thing to start with. And I think students struggle the most with what to start with. So if you're given a molarity STOIC problem, my suggestion is always, when you're trying to figure out what to start with, is always do something you can measure. So if you have milliliters or liters or grams of something that can be measured, that's the thing to start with. And then you're going to use the molarity as a conversion factor. There's one exception for this when you're actually trying to solve for molarity. Just a little bit more complicated, and then my suggestion is you solve for moles, and you'll find that usually liters or milliliters are available in the problem, and then you solve there. But let's take a look at how we actually apply that. Alright, so number 3 says how many milliliters of 0.6 molar HCl, so this is 0.6, and I always recommend doing this, writing down what you have, being clear about what the problem's asking. So it's 0.6 molar, and we're trying to find out milliliters, are needed to react completely with 14 grams of zinc. Okay, so first thing you always have to do if you have a reaction is get it to be balanced, and in order to do that, I just need to make 2 HCl. So the thing that I have here that can be measured is 14 grams of zinc, so that's what I'm going to start with. So if I have 14 grams of zinc, then what I know is, based on the molar mass of zinc, 65.39 grams of zinc is 1 mole of zinc. And then I need a mole-to-mole ratio. 1 mole of zinc is going to require 2 moles of HCl. Now here's where I use my 0.6 molar as a conversion factor. What I know is 0.6 moles, molar could be, the units for molar are moles per liter. So 0.6 moles of HCl is 1 liter of HCl. Now they're asking for the answer in milliliters, so I'm just going to add one more factor here. 1 liter of HCl is 1,000 milliliters. Okay, and then if I punch everything through, my calculator says 713.667 milliliters, and that's what I'm going to add into Quest, just because they're picky and they want more than the required sig figs. But when I'm writing this out in my notebook, I only have 1 sig fig here. I've got 2 here, so I'm limited to 1 sig fig. So my answer actually is 700 milliliters of HCl. Alright, let's take a look at this one. We add excess NaCl. I'm going to write this out as I do it. And this is excess, I'm just going to write that, to 44 milliliters of a solution of silver nitrate. Alright, so silver nitrate, and I have 44 milliliters. To form insoluble solid silver chloride. So that's going to precipitate out. It doesn't say what else we make, but we know that we're also going to make sodium nitrate. But the important thing here is that all of these are a 1:1 ratio. Okay. When it has been dried and weighed, the silver chloride is found to be 1.99 grams. Okay, and what we want to know is what is the molarity of the silver nitrate that we started with. So if you look at the silver nitrate, we are given the volume So in order to get molarity, molarity is moles over liters. I can convert that to liters. What I need to find is the moles. So I'm going to set up my stoich to find moles. Alright, so I'm going to start with what I can measure, right? I'm going to use this 44 milliliters down here. So I'm going to start with the 1.99 grams of silver chloride. And what I know is the mass of silver chloride, the molar mass, is that many grams, is 1 mole of silver chloride. And that 1 mole of silver chloride comes from 1 mole of silver nitrate. So if I punch this, what I get is 0.01389 moles of silver nitrate. Now, one of the things just as a practice you should do is I should not round this to sig figs. I need to keep as many decimal places basically as my calculator holds within reason. And I only round to sig figs at the very end of the problem. Okay, so don't make the mistake. Keep it in your calculator is the best thing to do. So I know how many moles I have. I know what my volume of the silver nitrate is, so I can find molarity is moles over liters. So that's going to be 0.01389 moles over 44 milliliters. If I divide that by 1,000, I get 0.044 liters. And my molarity ends up being 0.31557 molar, which is what I add into Quest. But if you look here, I've got 3 sig figs in my mass of silver chloride. I've got 2 sig figs here, so the answer I should report in my notebook is 0.32 molar. Okay, let's take a look at number 6. Alright, Listerine mouthwash is 21.6% ethyl alcohol, which is also known as ethanol, by volume. What mass of ethanol is contained in 20 milliliters of mouthwash? Okay, so let's start off with something we can weigh. I have 20 milliliters, and I'm just going to call it Listerine. And based on the density, that's the density of ethanol. So based on this percentage, what I know is that if I have 1 liter of Listerine, that I have, because this is milliliters down here, I'm going to go ahead and convert that to milliliters. I have 1,000 milliliters. 1 liter is 1,000 milliliters. And I can use my density here as a conversion factor. I can either say 0.789 grams over 1 milliliter or 1 milliliter over 0.789 grams. And because I want my units to cancel, I'm going to say 1 milliliter of Listerine is 0.789 grams of Listerine. Now I also know that Listerine is 21.6% ethyl alcohol by volume. So if I have 1 liter of Listerine, I have 0.216 liters of ethanol. And if I multiply that all out, I get 3.408 grams of ethanol. And let's see, from a sig fig standpoint, I have 3 and 3, so I should report in my notebook 3.41 grams of ethanol, also known as ethyl alcohol. All right, let's do one more. This is number 11. When 80 moles of calcium acetate are dissolved in enough water to make 298.2 milliliters of solution, what is the molarity of acetate ions? Okay, so what I'm doing is I'm taking calcium acetate. Acetate ion is a -1 charge, so I need 2 of those to balance out the calcium plus 2. If I put that in water, I'm not reacting it, I'm just making a solution, right? I end up with calcium plus 2 ions, plus acetate ions, but I have 2 of these for every 1 of these, right? So if I have 1 mole of this, I have 2 moles of this. Or if I have 1 molar of this, I have 2 molar of this. Okay? So I'm just going to take that 80 moles of calcium acetate, and for every 1 mole, and I'm just going to call it Ca, I have 2 moles of the acetate ion. Okay, so I end up with 160 moles, and then in order to find the molarity of the acetate ions, it's going to be the moles of the acetate ions over the liters of the acetate ion. So the moles are 160 over my liters. 298.2 milliliters is 0.2982 liters. And that's going to give me a molarity of 536.55 molar. And from my sig fig standpoint, let me see. I have 4 sig figs here, but only 1 sig fig here. So my answer in my notebook is actually 500 molar, which, believe it or not, is actually totally impossible. That's just way more solid that won't dissolve in here. But you'll get a feel for that as we go along in the course. Okay, I'm going to stop right there.